Here we go. Up to this point, we've dealt with, let's remind you, we've dealt with the sine, cosine, and tangent of right triangles. The reason this is so important is most things that we construct, most things that we build contains right angles. Talked about SOHCAHTOA, sine, cosine, and tangent. The sine is the ratio of the opposite side to the hypotenuse of a right triangle. The cosine is the ratio of the adjacent side to the hypotenuse of a right triangle. The tangent is the ratio of the opposite to adjacent side of a right triangle. But what if we don't have a right triangle? That's where these last two laws that we're going to go over comes into play. We have the law of sines and the law of cosines. Law of sines is very, very easy to use. The law of sines states this, that you have the sine of an angle A over some side A is equal to, okay, the sine of an angle B over side B. And the sine of angle B over side B is equal to the sine of angle C over side C. You have what's called proportions here. Everybody knows how to solve proportions, and if you can solve proportions, like I said, these are going to be extremely easy problems. One thing you do need to know, the most important part of this, notice where angle B is, because we're not dealing with right triangles anymore. We're dealing with what's called oblique triangles. We're dealing with acute and obtuse triangles. Look where angle B is at. Look where side B is located. Angle B and side B are always across from each other. They're opposite of each other. Angle A and side A are always opposite of each other. Angle C and side C are always opposite of each other. So that's extremely important that you set it up like that. That you know if this is angle C, then side C must be the one across from it. But sine A over A equals sine B over B. It's easy, very easy formula to remember. And not only that, notice it's got three of them here. Sine A over A equals sine C over C. Sine B over B equals sine C over C. Okay, that's your law of sines. Let's use it. Find x and round to the nearest 10. I do want to remind you before we go into these problems, if you have to find something like the sine of 35, that is a number. The sine of 35 is a decimal number. Okay, does everybody understand that? It's still, if you were dealing with a right triangle, it still would be the ratio of the opposite side to the hypotenuse. It's still that stuff. So dealing with this problem here, and they've even done you the favor of calling the sides A, B, and C. The reminder that, look where angle A is at. Angle A is 97 degrees. Jagger, can you tell me how big side A is? Which one is side A? If this is angle A, side A is located opposite or across from it. This would be side A. Side A is 16. Something else I didn't point out a while ago. Notice that angles are named with capital letters. Sides are named with lowercase letters. That's something you need to know. So if angle A is 97 degrees, side A is 16. Angle C is 21 degrees. Dylan C. How big is side C? If this is angle C, you know where side C is located? X. That's it. It's the one across from it. So here's how you set it up. Sine of A over A, the sine of 97 degrees over A, 16, equals the sine of C, which is 21 degrees, over C. Solve the proportion, you're done. Now, let me throw this out there. On your plan test, on the ACT, they're multiple choice. And not only are they multiple choice, but I don't know if you knew this or not, you're not required to use a calculator on the ACT. So my question for you is, how in the world, because these problems are on there, how in the world could you work that problem without using a calculator? Yeah, magic, close. They're not going to, here's how they're going to list your answer on the ACT. And then we'll talk about that, and then we'll actually type it in and find a decimal answer. They won't give you a decimal answer. How do you solve that proportion? What's the first two things you multiply? Proportions. 16 times sine of 21. Then you divide by what? That's how they're going to leave their answer. Does that make sense? They just won't multiply it out. They'll test your ability to know that what's x equal to by doing that right there. That's how you'll solve the proportion. Is you're going to type it in like this. You're going to do, and let me pull up my calculator. You would type it in as 16 times sine of 21 divided by sine of 97. But they would leave it, A, B, C, D, they would leave your multiple choice answer looking like that. You don't actually have to type it in. But let's get a decimal. Clear? The sine of 21 times 16, and some of you will have to do it one step at a time. Sine 21, enter. Times 16, enter. Divided by sine of 97, enter. I get 5.77 or about 5.8. So x is about 5.8. Done. That's all you're going to do. Now question, we weren't asked to do it, but how in the world would I find side B? Does anybody know? I'll give you the first step. The sine of 97 degrees over 16 equals, close, the sine of something over, let's call it y, sine of something over y. But we can't have two different variables, right? So how in the world do we find that other angle? Yeah, that's it. The three angles add up to 180. So if you got two of the angles and you want to find this other side as well, that'd be 118. I believe that leaves 68 degrees. Sine of 68. That's how you would solve it. Sine of 97 over 16 equals the sine of 68 over y. Type that in, and that would tell you what the other side is equal to. Could I use Pythagorean theorem to find out what the other side is equal to? No. Why not? It's not a right triangle. But I'd be close. 97 degrees, that's not too far off from a right triangle, but you can't. You can only use Pythagorean theorem on a right triangle. Another one. Little bit different here. Here you're dealing with looking for an angle. You start out the exact same way. The sine of 45, law of sine says the sine of A over A equals sine of B over B equals sine of C over C, but I have H, J's, and K's here. If you want to make the H, J's, and K's and A, B's, and C's, it doesn't matter. Because here's what it amounts to. The sine of this angle over this equals the sine of this angle over the side across from it. That's what it amounts to. You don't have to call it A, B, and C if you don't want to. The sine of 45 over 8, which would be the sine of A over A if you want to think of it like that, equals the sine of X over 10. To solve that, Colton, what two things do I multiply together first? Good. Sine of 45 and 10. Let's do that. I can get my calculator pulled over. Clear. Sine of 45 times 10. So sine 45, enter, times 10, enter. What do I do next, Alex? I multiplied these two. Now I've got to divide by 8. Okay, everybody good? Multiply these two, multiply this times this, divide by this, but here's the problem. Everybody listen real close to what I'm about to say. That doesn't tell you what x equals. If you multiply these two and divide by this, that tells you what this equals. That makes sense. That doesn't tell you what x is, that tells you what sine of x is. So I now have the sine of x is equal to, pull up my calculator, 0.8839, rounded, 0.8839. I'm not done yet. Because I'm interested in what is the angle. And this kind of goes back and hopefully it'll make more sense if you think about when we were looking for angles back when we were dealing with right triangles, what we had to do next. Matt, I need to get rid of this sign. I want to know what x is equal to. How can I move that sign over there? Remember? The sine of x. Does anybody remember what it was called? How do I move a sine over? Inverse sine. To get a sine from one side to the other side. And here's your rule. Anytime you're looking for an angle, you will always do the inverse sign of the other side. So going back to my calculator, look, I've still got that up there. So what I can do is the inverse sign of my answer, enter. 62.11, so about 62 degrees. So x is about 62 degrees. Now I want to go ahead and address something to save Miss Green some energy next year and to save me some energy the next year when I have you in pre-calculus. Let me show you something a little different. So the sine of 62, let me find it. Sine of 62 degrees should be somewhere close to that 0.8838, right? 0.8829. It was a rounded answer. But let me show you an issue I have. Look at the sine of 118. Notice something about that? They're the same thing. The sine of 62 and the sine of 118 is the same thing. Let me show you something else. The sine of 120 and the sine of 60. The sine of 50 and the sine of 130. Weird. The sine of 45 and the sine of 135. Last one. The sine of 179 and the sine of 1. Has anybody caught on the relationship between those two numbers that I typed in? They add up to 180. They're supplementary. Supplementary angles have the same sign. So here's what you got to be careful of. Your calculator will lie to you sometimes. This is 62 degrees, or it could be its supplement. The sine of 62, yes, the sine of 62 does equal 0.8839. If you solve that right there, this times this, divided by this, you get sine of x is 0.8839. 62 is an answer, but we have another thing that could be an answer, or 118 degrees. Like I said, normally you don't cover that geometry. I want to go ahead and give you a taste of it. Supplements have the same sign. I'm going to write that down. Supplements, I put it in my notes. Supplements have the same, not S-I-G-N, S-I-N-E sign. Supplements have the same sign. So 62 or 118, but can anybody tell me why I can throw, well, could I? Yeah, I can throw 118 probably in the garbage. No, I can't either, not on this one. Could 118 be a possible answer on this? Yes, it could. Sometimes you can throw it out the window. Sometimes you're going to get something like 150 as an answer, and you could throw it out because you know they have to add up to 180. 118 is a possibility here. 118 is a possibility. Now, if this were 118, do you see that your third angle would be really tiny? That'd be 45, 118, that'd be 163. That would only leave 17 degrees for your third angle, but it's possible. Because is that drawn to scale? No. No. Okay, let's do another. Law of cosines. The law of cosines. I wish I had thrown in another one of those. Maybe we'll pull one off your homework in just a second. The law of cosines is even easier than the law of sines. And here's what I want you to do. Take a second and write these down. I'll let you use them on your test if you've got them written down. You can write them on that formula sheet. That'd be great. Sometimes the law of sines will not work. How do I know when to use the law of sine or law of cosines here? Well, when the law of sines does not work. Try law of sines first. It might be a little bit faster because there's a lot of plugging in here, and that's all it is. Honestly, it's a formula. You plug stuff in, you got an answer. That's all the law of cosines is. Try first the law of sines. See, is the law of sines going to work? Let's give you a problem. Let's say this is 6, this is 7, this is 30 degrees, and this is x. Is the law of sines going to work there? Sure. Sine of 30 over 6 equals sine of x over 7. What about this problem? This is 6. This is 7. This is 30 degrees. And this is x. Sine of x over 7 equals the sine of, hang on. You see that it's not going to work there. The law of sines states the sine of this angle over this side equals the sine of this angle over this side. It works here. The law of sines states that the sine of this angle over this side equals the sine of this angle over this side. The law of sines would not work for this problem. Again, the book's going to give this difficult explanation of when to use law of sines, when to use law of cosines. Use the law of sines if it works. If it doesn't work, use law of cosines. That's my explanation. That's the easy way to remember it. Here we go. Look at this problem. The law of sines would not work here. The way that the book explains it's with like a side angle side type scenario. If you have a side angle side scenario, do you see side angle side here? If you have a side angle side scenario and you're looking for the opposite side, you're going to have to use law of cosines. You could try to use law of sines. The sine of 28 over x equals you don't have no other angles. You can't finish it. So that's where we use the law of cosines. And you have 3 options to choose from. You have a squared equals b squared plus c squared minus 2bc times the cosine of a. You have b squared equals a squared plus c squared, bless you, minus 2ac times the cosine of b. Or you have c squared equals a squared plus b squared minus 2ab times the cosine of c. How do I have all those 3 of those formulas memorized? I don't. I have one memorized. It's the same formula, guys. A squared, b squared, c squared. B and c are here. B and c are here. Whatever angle or whatever side this is, that angle's there. It's the same thing on the other ones. If A and C are here, it's going to be here, and whatever this is, that's going to be the angle. A and B are here, so it's there also. Whatever this angle is, that's what side is over here. It's the same formula. Because watch, look at the problem. I'm looking for side C. I'm given angle C. Which one do I have to use? I'm given angle C. The third one. This is the only one I can use. That's the only one that involves angle C. I'm plugging in angle C, so I have to use this formula. But question, watch this. Does it matter what those are called? No. Now which one would I use? A. If I called that B, which one would I use? B. So if you want to, guys, if for the sake of ACT, because they're not going to give it to, well, I don't know. I take it back. I don't think they give it to you on ACT. They might. If you want to just memorize one for your ACT, and then just scribble it out. If you need angle A, then just scribble this out and put an angle A there, and then that way you can just use whichever one you need. But anyway, we're going to use that third formula. Let me clear this. We're going to use c squared. Notice this is a little c. You can't square an angle, right? Until you get to pre-calculus. C squared equals a squared plus b squared minus 2ab times the cosine of c. And you just plug everything in. Dylan B, do we have c? Little c. What is little c? Here's big C. Dylan, where's little c located? Side C. Little c, little a, little b, little c, those are all sides. If this is angle C, then side C is going to be x. So you have x squared. Let me do a different color here. You have x squared. I'm plugging it in. Equals, Hunter, what's A? 9 squared. What is Carly B, little b? 11 squared. Minus 2 times 9 times 11 times the cosine of trace, what's C, big C? Because, guys, we can only find the sine, cosine, and tangent of angles. Can't find the sine, cosine, and tangent of a side. So that'll always be an angle. So how do we work that? We type all that in our calculators, and we're nearly done. All right. So we take our calculator out. And you see why I say these are pretty easy? It's just plugging stuff in your calculator. And I don't care for you to use, like I said on the test, I don't care for you to use these big calculators because you can actually type that entire thing in. And you can always check one out for the ACT as well. 9 squared plus 11 squared minus 2 times 9 times 11, 2 times 9 times 11 times the cosine of 28. Enter. Oop, got messed up. Cosine of 28. Enter. 27.17. Is that 27.17? Is this side 27.17? Does anybody see something I hadn't done yet? Look at your formula. X squared equals all that stuff. How do I get rid of a square? And if you want to do it as you go, if you just want to type this in once, could I just square root all that? Sure. Square root your answer. Oops. So we're going to do the square root. And like I said, I recommend just doing it as you go. Just type it in as you go. 5.2. So this side, 5.2. Done. Just type it in the formula. That's all the law of cosines is. Any questions before we move on? Probably the last problem. No, a couple of work problems and we're done. We're looking for an angle now. Does everybody notice that? Not looking for a side length. We're given M, P, and Q, sides M, P's, and Q's, but our formulas has A's, B's, and C's. So what do? We scribble out M, we scribble out P, and we scribble out Q. And whatever formula you want to use, this is the angle I'm looking for. If I want to use the first formula, call that angle A. Angles don't matter. The A, B's, and C, they don't matter, okay? Because all three of the formulas are the exact same thing. If I'm looking for angle A, let's go back to my formulas. There they are. If I'm looking for angle A, this is the only formula that involves angle A. So I'm going to use A squared equals B squared plus C squared. Starts out like the Pythagorean theorem, similar. Minus 2 times, somebody don't look and tell me if they know what goes next. 2 times the cosine of A. After a few times, you'll have this one out. Plug in everything you know. I've labeled angle A, B, and C. Riley, what's little a now? Find big A, find angle A, and tell me what little a is. 8. Reminder, for those of you that have no idea how he got that. If this is angle A, side A is located straight across from it. So we've got 8 squared equals, Briley, tell me what B is.
6 squared.
Good. So, well, B is 6, you were right. So 8 squared equals 6 squared plus, Jagger, what is C? 3 squared. So C is 3. Minus 2 times 6 times 3 times the cosine of A. Or actually, I'm going to put, just to let you know that that is what we're looking for, cosine of X. Here's one of the biggest mistakes. This is one of the only things that people have issues with. Watch as I simplify this. You might want to write this down and put a big star next to it. 8 squared is 64. And you could do this all on your calculator. 6 squared is 36. 3 squared is 9. Minus 2 times 6 times 3, that is 36, times the cosine of X. Here's what not to do. Watch real close. 36. Oh, look, there's a minus 36. I can just cancel those out. No. There's a big difference there. Look at this problem. Let's say that you were solving this equation. 4 equals 36 minus 36x. Can I put 36 and 36 together here? No. Why not? That x, they're not like terms. That x is attached to the 36x. This doesn't have an x on it. I can't put those together. It's very tempting to do it, though, because they're all three right there next to each other. Right there is the main mistake that people make in this formula. Look and see what your like terms are. First off, is 36 and 9 like terms? Yes. You can add those together. But can I do minus 36 stuff? You see that this 36 has stuff attached to it. This 36 has your unknown attached to it. You can combine these two, but whatever you do, do not combine it with this yet. So you have 64 equals 45 minus 36 times cosine of x. And a lot of people say, well, what are you going to do then? The same thing you would do here. What would you do here? What would you move first? This 36, right? And how would you get rid of this 36? You're going to do the same thing on this problem. You're going to take this 45, and you're going to move it first by doing minus 45, and you're left with 19. Now I got to get rid of the negative 36. Reminder of what we just said. Dylan C, how do I get rid of this 36? Divide it. So divide by negative 36, and y'all can type that in your calculator if you want to. But look, it's not equal to x again. It's equal to the cosine of x. So let's come over here, and I'm going to write, so the cosine of x is equal to, you know what, I'm not even going to divide it yet. I'm going to leave it as negative 19 over 36. When you're looking for angles, you'll always have this last step. When you're dealing with sine, cosine, and tangent, and you're looking for an angle, you will always have this last step. You're going to have to move cosine over. How do you move cosine over? Inverse. Inverse cosine. So let's take out our calculator and let's type in the inverse cosine of, and like, you see why I said you don't have to divide it? Because you can just type it in as negative 19 over 36. I get 121, let's just call it 122 degrees. X equals, or is about 122 degrees. Now, let me remind you of something. A while ago, we found out that the sign of supplements were equal. Supplements had the same sign. What about, let's try cosines. Let's just double check, and this is what you're going to like about the law of cosines. Let me pull my calculator back up. Let's make sure that the cosines of supplements don't have the same answers. Cosine of 20. 0.939. Cosine of 160. Okay, good. One is positive, one is negative. So, do the cosines of supplements also equal? Do cosines, the supplements also have the same cosines? No. So you know what that means is when you get 122 as an answer, guess what? That's the only answer. X is 122 degrees. Now, you're not going to be asked to do this on the test, I don't think. But what if, now that I've got that answer, could I find angles B and C? Look what you've got now. We just learned the law of sines. Let me clear all this and just show you. This is about 122 degrees. Can I use the law of sines now? If I were asked to find the angle P and Q here, I told you I don't really like using that 122 because it's a rounded answer. But if I was asked to find this angle, could I say the sine of 122 degrees over 8 equals the sine of Q over 3? Sure. Now that you found that M is 122 degrees, you could use law of sines, you could find Q, and then you could use the angle, the triangle angle sum postulate, the three angles add up to 180 to find your third missing. Okay, last problem, or nearly last problem, next to last problem. At 10 feet away from the base of a tree, okay, here's a tree, and you're 10 feet away from it. At 10 feet away from the base of a tree, the angle to the top of the tree makes with the ground is 61 degrees. If the tree grows at an angle of 78 degrees with respect to the ground, didn't draw that right, did I? How tall is the tree to the nearest foot? Let me erase that and let's draw it right. I drew that tree perpendicular to the ground. It's not. The tree grows at an angle of 78 degrees with respect to the ground, so it's kind of growing like this. So that's a 78 degree angle. It's growing crooked. And you're standing right here, and the angle that it makes with the top of the tree is 61 degrees. And you're standing 10 feet away. And we want to know, how tall is the tree? This is a good problem. Because I'm about to ask you if it's law of sines, law of cosines, and unfortunately, if you don't really think about it, you might give me the wrong answer. Look into it and tell me why or why not. Is this law of sines? Because I told you, use the law of sines. If it doesn't work, then go to law of cosines. Is this a law of sines problem or a law of cosines problem? To use the law of sines, you do the sine of this over this. Let's write that down. The sine of 61 over x. That's what the law of sines states. Equals, if I want to use the law of sines, well, I don't have this angle because it would have to be equals this over 10, right? Do we have that angle?
Yeah.
This is one of the most overlooked things when you're dealing with law of sines and cosines. If you have two angles, go ahead, you've got the third angle too. If this is 61, this is 78, that's 139. I believe that would make this 41 degrees. So as everybody see, I can use law of sines here. Law of 61 over x equals, the sine of 61 over x equals sine of 41 over 10. Do you see how this ties in also with old stuff that we did? Can you tell me, is that tree going to be taller than 10 foot or shorter than 10 foot? You remember that lesson? You have a triangle. In that triangle, you have a 61 degree, a 78 degree, and a 41 degree angle. The shortest side is always across from the shortest angle. The largest side is always across from the largest angle. So you got 10 is across from 41. Is that tree going to be taller than 10 foot or shorter than 10 foot? There's taller. Okay, let's type this in there. And this is one of the easy ones. We're not looking for an angle. We've got all of our angles. We're looking for a side. So to type this into our calculator, and I'll let y'all do it as I say this, the sine of 61 times 10, and then whatever you get, divide it by the sine of 41. The sine of 61 times 10, whatever you get, divided by the sine of 41, and let me know when you get an answer. Good. So about 13.3 feet tall. Anybody else get that? And you would type it in as a sine of 61. There you go. We'll type it in right here just to show you. Sine of 61, enter, times 10, enter, divided by sine 41, enter. 13.331. Okay? Any questions? So the tree is a little bit bigger than 10 feet. And to find that third side, I don't know why you would need it. The distance from where you are to the top of the tree, could you use Pythagorean theorem? No, it's not a right triangle. Don't ever use Pythagorean theorem unless you have a right triangle. Last problem. It says solve the triangle. So yeah, I like to, maybe you will have one of these on your test. To solve this triangle, we're going to use both. Because look, law of sines. Attempt to use the law of sines. The sine of A over A, okay, you don't have that angle. That has to be your x. Equals the sine, well, you don't have any of the angles. So you can't use law of sines. You're going to have at least one angle to use law of sines, if not two angles. So here we go. Let's attempt law of cosines. Since we're dealing with angle A, and I'm just finding this first. It doesn't matter. You can find B first if you want to. Since I'm dealing with angle A, we're going to use A squared equals B squared plus C squared minus 2BC times the cosine of A. Law of cosines. Plug everything in for me. Well, I guess, yeah, we got B and C there. Colton, what's little a? Good. So we have 15 squared equals, what's little b, Alex? Good. Plus, what's little c, Matt? Good. Minus 2 times 12 times 13 times the cosine of A. Now, for all of you that attempt to go above and beyond and just are always looking for a different way of doing things, let me show you. If you want to type this whole thing into your calculator at once, this is what we do in pre-cal just to save some time. let me show you something you can do. This and this can be moved over. You have 15 squared. How do I move 12 squared over? It's a positive, right? So make it minus 12 squared, and 13 squared will be minus 13 squared. So if you want to move those two over, you can subtract them. Now, you've got to be careful. How could I move this stuff over? I've moved this. This stuff is being multiplied, right? So I can move it over by doing divided by negative 2 times 12 times 13. Now, that's equal to the cosine of A. So if you want to really just reach out there and do something great, how could I get rid of that cosine as I'm going? To move it over, you're going to have to do the inverse cosine. So if you want to type it all in at the same time, the inverse cosine of all that stuff, and then you go straight to the answer. That makes sense. If you don't want to do that, do a piece at a time. Break it down, combine like terms, then subtract them, then divide by this stuff, and then do the inverse cosine. You can do it either way. You got an answer, Alex? No. Here you go. I'll try the top one. So the inverse cosine. Now you got to put this whole top in parentheses. That would be a little confusing. 15 squared minus 12 squared minus 13 squared. Close parentheses, divided by the whole bottom, negative 2 times 12 times 13. Close parentheses, I get about 73 degrees. And I'm going to leave that on my calculator. That angle X is right at 73 degrees. Now that you found that, since we're asked to solve the triangle, we've got to find all the sides. Or excuse me, all the angles. Got all the sides. We cannot use Pythagorean theorem. It's not a right triangle. So here we go at an attempt to find another angle. Since I now have that is 73 degrees, I can say that the sine of 73 over, anybody? 15 is equal to, what do you want to find now, B or C? Doesn't really matter, right? The sine of, finish this statement. The sine of what over 12? B. Or you could have done equals the sine of C over 13. You can done either one using law of sines. As you're typing this in, let me throw this out there though. You're building a bridge, right? This is not exact. Unless you use this on your calculator. So my suggestion is, if you've got a calculator to where you can do this, the sine of the answer. That way you're doing the sine of this whole thing and not the sine of 73. The sine of your answer times 12. And then you've got to divide that by 15. And that's our answer, right? When you're using law of sines, if you do this times this, and then you divide it by what's left, that's going to tell you what the sine of B is equal to. The sine of B is equal to 0.7675. How do I get rid of sine? It's careful. Inverse sine. You were on the right track. I knew where you were going. The inverse sine of the answer, and you get 50 degrees. Or, so, good. B is 50 degrees or 130. If you're using the law of sines to find an angle, supplements have the same signs. The sine of 50 is that, and I wish your calculator would tell you that. I wish your calculator wouldn't just say, oh, it's 50, 50.13. No, it's 50.13, or it's 129.8784 or something like that. Okay. It's not only that, it's got another one, but you know what? Look at this problem. B is 50 degrees or 130 degrees. Can't be. Look, guys, this is already 73. The three angles in a triangle always add up to 180. 73 and 130 don't jive. So therefore, 50 is going to be the only solution there. So you've got 73, you've got 50, and now that you have two angles You have the third one that's 123 and 57 degrees. You've solved it. And you can check yourself. Look, smallest angle, smallest side. Just a little bit bigger, just a little bit bigger. And slightly bigger than that leads to slightly bigger than that. That's the three angles in that triangle. So once again, if you're dealing with a right triangle, we use SOHCAHTOA, sine equals opposite over hypotenuse and all that. If you're dealing with an oblique triangle, whether it be acute or obtuse, use the law of sines and use the law of cosines.